pharmaceutical manufacturing industry.
So with your permission, we would like you to
One second.
Prasad garu.
Hello.
Sir, Prasad garu, you are not audible andi.
Hello.
Yes, sir. Biswajit, you
You
are
can
audible,
hear
sir.
me? Okay.
Prasad garu, you are not audible andi.
Sir, now okay na sir?
Yes, yes. Please check before that, sir.
Sir, okay na
Proceed
sir?
on, proceed on.
Okay, sir. So today, welcome to the fourth day sessions. Today we have 4 sessions. As a first session, Dr. Biswajit Nayak is the resource person. So Dr. Biswajit Nayak, working as a director of Advanced Analytics and Data Science, Grid Analytics India Private Limited. So we have 20 years of professional experience spanning across ITES, advanced predictive analytics, data science, software product marketing, consulting, professional training. Biswajit has the ability and capacity to solve mission critical business and research problem by applying advanced analytics and data science. Biswajit and his team servicing over 600 customers virtually representative from every industry such as BFSI, manufacturing, pharmaceuticals, healthcare, research, educational institutions. Biswajit and his team successfully delivered over 2,200 talks in workshops, seminars, paper presentation in industries, research and academic institutions, including ISIS, IITs, NITs, universities, and research labs such as CSIR, ICAR, DRDO, and Department of Space. Biswajit domain expertise certainly adds value in the area of data science, advanced analytics, AI, deep learning, statistics, optimization, and IoT. He completed the certifications Data Science Certified Professional from TIBCO Academy and Data Science Certified Associated from TIBCO Academy. So it is an esteemed honor to welcome such a highly knowledgeable and technically adept individual as our resource person for this FDP. Sir, the session is now yours, sir. Kindly start our presentation, sir.
Okay. Namaskaram to all the participants in the other side. On behalf of SPECE for women and on behalf of management of the SPECE for women and on behalf of Grid Analytics, we welcome each of you for this session on a machine learning approach to predict heart disease, right? So this will be the theme of the session. And before getting started, I would like to extend my gratitude to the professor for this nice introduction and setting the platform to way forward. Just have a quick response. My audio quality is clear. You can hear crystal clear my audio. Can you please prompt?
Yes.
Hello, can you please prompt loudly from the other side? My
Yes, sir.
audio quality is clear.
Yes, sir. It is clear.
Okay, wonderful. Can you view my screen now? I have shared my screen. The screen appears with the invitation and with the theme. You can view my screen.
Yes, sir. Yes, screen is visible.
And the screen is visible.
Yes, sir. It's visible, sir.
Okay, the screen size in proper size. You can read the content from the screen.
Yes, sir.
Yes,
We
sir.
can read it, sir.
Okay, wonderful. Thank you. So let's get started because we had a quick check everything is working fine for today. Let's have a quick check, then let's start. Right. So the session will be on a machine learning approach to predict heart disease. Right. What is all about the machine learning, and the format of the session will be, it will be 80-20. 20% will be the theory and 80% will be the practical. And during the practical and during the predictive model management life cycle, we will be using a software called Statistica, which happens to be one of the leader in data science, machine learning, artificial intelligence as a commercial software. So you can view my screen, the data science discipline. Hello. Can you view my screen?
Yes, sir.
Data
Yes,
science.
sir. It is visible,
Yes,
sir.
sir. Yes,
Yes,
sir.
sir,
It's
it's
visible. Yes.
visible.
Wonderful,
Yes, yes.
wonderful. Yeah,
Visible.
so this is the data science is all about. That is the reason the data science has become very, very popular, right? And we have been talking about the generative AI, LLM. All these are also a part of the data science. So what the data science includes? Data science includes the databases and data processing. Data science includes the visualization, right? How you can build your story using the graphs, charts, icon plots, right? And you can tell your data story through visualization. Then data science also includes statistics. Data science also includes pattern recognition. Data science also includes the machine learning in line with your theme, a machine learning approach to predict heart disease. Data science also includes the data mining. Data science also includes the AI, artificial intelligence, right? And if I split these infographics into the two parts, right and left, in the left-hand side, what I see, the databases and data processing, visualization, statistics, right? So that differentiate between a data analyst, business analyst, financial analyst, and the right hand side and a data scientist. Suppose you have the skill of the left hand side, databases and data processing, visualization, statistics, then you qualify as a data analyst, business analyst, financial analyst, so and so forth. If you have the combination of this left and right, in addition to these three components, you have the understanding about machine learning, data mining, neurocomputing, AI, then you become a data scientist, right? And what you see in the upper sphere, right? Business strategy, domain knowledge, communication, presentation, inclusiveness, problem solving, business analyze. These are the soft skills, right? So if you have all the skill, what you see in this infographics, you become a rock star data scientist, right? And all you we know and agree that a data scientist has become one of the hottest career option today, right? So these are the ingredients you should have in order to prepare or cook a rock star data scientist. So what is this all about the AI? What we saw in the last infographics, we saw, right? AI is a part of AI is a part of data science, right? Again, under the artificial intelligence, we have the machine learning, right? We have the deep learning, we have the generative AI, large language models, generative pre-trained transformers. The GPT-4 and the Chat GPT is a product of AI. It's a product of AI, right? So many of things they have been creating their own Chat GPT by using these large language models, so and so forth, right? What typically we have been doing the NLP in the past, this has been extended to a large, right? This is an extension of the NLP, which is popularly known as now is the large language models. So let's get started. And whenever we carry out any of the projects, right? Whenever we carry out any of the projects under the data science or machine learning or the artificial intelligence, there are certain these the industry expert recommendation framework for data mining, data science. What do you see in the right hand side? This is one of the framework for the best practices, or there is one of the recommendation for the best practices known as the cross industry standard process for data mining, or in the short form it is known as the CRISP, CRISP, right? So whenever you undertake any of the data mining projects, data science projects, machine learning projects, AI projects, suppose you follow this framework, right? Like business understanding, for your case, the academician, it could be a research understanding. Then we have the data understanding, then data preparation, then modeling, then evaluation, deployment. If you follow this scripts framework, your chances of winning and completing the projects will be much more higher. What the average say, the chances of completion and winning of projects will be 40 to 40 to 50% higher if you follow this framework and if you don't follow this framework, right? So this is the CRISP framework. Again, another infographics I would like to share. Whatsoever we do, like data science, machine learning, artificial intelligence, right? Broadly, we carry out the four type of analytics. Under the hood of the four type of analytics, initially we do the descriptive analytics, right? What happened? The purpose of the descriptive analytics, once we are dealing with the raw data, right? We wanted to we need to understand the characteristics and the nature of the data, the inferential statistics, theory of central theorem theory. These all are part of the descriptive analytics. Then the moving up, we have something called diagnostic analytics, right? So whenever we deal with the multiple parameters or the multiple input, we wanted to figure it out, and this is one of the greatest challenge of the researcher when you are doing the project, right? To include or to exclude the input parameters that we are going to experience in a couple of minutes practically how we do that, right? Then the predictive analytics. Moving up, we have the predictive analytics, right? So the predictive analytics is largely is like for the forecasting, for the prediction, for the scoring, like what would be the weather of tomorrow, what would be the sales of Reliance tomorrow, or maybe in a week, right? So the prediction, forecasting, that's what we do by applying the various algorithm, by regression, classification, depending on the data you have in hand, the raw data you have in hand, right? Depending on the nature and the characteristics of the data. Then we have something called prescriptive analytics, right? Suppose we predict something which is not very uh, which is not in line with our expectation. Under the prescriptive analytics, we recommend something, we prescribe something, right? In order to prevent that event to happen. The prevention is better than cure kind of theory, right? So we can prevent some corrective measure, we can prescribe some corrective measure to control that event, right? So this is like whatsoever activities we do that falls under this four type of analytics. Another analytics is coming up called cognitive analytics that deals more into the human psychology, right? And the prescriptive analytics is also known as your expert system or recommended system, right? Suppose you come across with a terminology like expert system or recommended system, don't get confused. That is known as prescriptive analytics. Fine. So let's get started. I'm using a software, as I said, I am using a software called Statistica. In the meanwhile, can you tell me you can view my screen?
Yes, sir.
Hello.
Yes,
From
sir.
the
Yes,
other
sir.
side, the screen is clear. You can read the
Yes, sir.
content from the screen. You can read the content from the screen. Hello.
No, sir, it's not visible.
Sir, no content on the screen.
Okay, so you see a
It's
blank
a
screen like file, home,
yes,
statistics,
sir.
this kind of thing.
Yes, sir.
Yes, sir. Yes,
Okay,
sir.
wonderful.
It's a blank.
Wonderful. Yeah, the screen is blank. Yeah. So I'm pulling a data in line with our theme. We are approaching to solve a heart disease prediction, right? So I'm pulling a data. The software provides 100 of the example data set for your self-paced learning or the self-paced practice, right? So I pulled a data in the name of the heart disease dot star that is inbuilt in our example data set, Statistica. And you can view, you follow my pointer, you can view there are 17 variables. The V denotes to column. You can see these V denotes to column and 463 C denotes to the cases. These are the historical data collected when the patient has visited to the doctor, and these are the different parameters. If I go to the data, if I wanted to view the all specification, you can see the specification. This data set consists of the blood pressure level, systolic blood pressure, tobacco intake level, tobacco intake, cholesterol level, LDL cholesterol, audicity, family history, stress level, so on and so forth. Fine. And out of this 17 column, there is one column which consists of my target variable in the name of the coronary heart disease. You can see 17 variable, right? The name of the variable is the coronary heart disease. And these variable labeled in classes, present and absent, right? And these classes has been labeled on the basis of the visit of the patient. It is a historical data. Fine. So I would urge all the participants, you please keep the two framework in your mind. One is the CRISP framework, right? Because we will be following the Statistica comply to the CRISP framework, and we will follow the CRISP framework in order to this for this heart disease prediction. Fine. So may I ask you, it would be a regression problem or it would be a classification problem? I have 17 number of variables. My target variables are labeled in classes, present, absent, right? When my target variables are labeled in classes, then it becomes a classification problem, right? So my problem statement converted into a prediction classification problem, right? So once I receive a new data, the 463, 464 and onward patient, I should have the ability to predict the status of this heart disease, whether it will be the present or absent. Fine. So let's get into that. First, you see, by taking that, we have built, we have developed an API, right? I will tell you the process, how we have done that. I go to the heart disease API. I run the heart disease API. Can you view my screen?
Good afternoon, sir.
Yeah, can you view my screen? The prediction of heart disease, a
Yes, sir.
user interface.
Yes, sir. Yes, sir.
Okay, right. So we have developed an
Afternoon, sir.
API. Yeah, we have developed an API. So now I am receiving
Sir.
the patient number once. Hello.
Sir,
Hello.
can I
Please
ask
continue,
one
sir.
thing,
No
sir?
problem.
We will have a questionnaire session. We have a defined time for the question answer session, right? I have kept for the 10 minutes for the question answer session. You can place all your queries you have in mind.
Thank you, sir. Thank you, sir.
Thank you for your understanding and passion. Yeah. So we got this API, right? So now I am receiving the patient number 464, right? 464. I have receiving the patient number 464 sample data. I have got the data for the purpose of demonstration. So I have got the data, the sample data, right? So this is the patient number 464. Now I will be check the status of this patient, check status, right? What you can view from the screen, this 464 number of patient has 78% probability. You see, probability present, probability of positive result is 0.78, right? So we have predicted, our model has predicted 78% probabilities are there. This new patient, which is 464, right? What we have predicted, we can claim an accuracy of 78%. And you see probability underscore absent. The probability of negative result will be 0.22, which is 22%. There are possibilities he or she may not have the heart disease, right? The predictive analytics. Fine. And what you see in my pointer, I'm highlighting, this is the diagnostic analytics, right? I got an importance plot, popularly known as also feature engineering, right? You people understand the feature engineering is very well but the feature engineering is also known as feature selection, right? The feature engineering is also known as descriptor screening. The feature engineering is also known as your variable screening, but the purpose remains same. It's the diagnostic analytics. Out of the 16 parameters we had, we wanted to, in a click of a button, we wanted to understand, identify which of the variables contributes maximum to the status of heart disease. What it indicates, the age. Age is contributing the maximum to the heart disease, followed by tobacco intake, right? So and so forth. So this is the importance plot. Depending on this importance, suppose you are dealing with a very, very large number of variables, right? You can exclude, right? Depending on your judgment, you can exclude or the include, fine, depending on the requirement of your projects. Fine. Then after the diagnostic analytics, we move to the predictive analytics. Under the predictive analytics, we found, right, we created a API. I am right, but I can also act as a doctor, right? So in absence of a doctor also, through this power of this model, very well I can predict, and also I can get in like the confidence, right? I can, what I'm predicting, I have enough evidence to claim that confidence. Fine. So this is the heart disease. So after the predictive analytics, what was there? After the predictive analysis, the prescriptive analytics. We wanted to control this event. We wanted to prevent this event. We don't want, we wanted to, as a doctor, we wanted to recommend something which will change the status from the predictive analytics, like from present to absent. So in the diagnostic analytics, we found the age is contributing maximum. We do not have a control over age. We cannot ask our patient to reduce or the age because we don't have any control. But followed by the tobacco intake, we can very well recommend our patient, you need to quit the tobacco, right? if we wanted to control the heart disease, right? So let's do a simulation to get a sense. Tobacco intake is my 0, right? And tobacco intake is low. Fine. Let's check the status. After the diagnostic analytics, I recommended check status. What you can view from the screen now? Hello? Can you please someone respond from the audience
Yes,
side
sir.
or from the
Sir,
organizer
yes,
side?
the probability
Yes, sir, no
of
issue.
negativity is 71%.
Yeah, now the
Negative.
status changed because
Absent.
yeah. So now the status changed because after the diagnostic analytics, we found the root causes which was contributing to the status of the heart disease. Then we prescribe under the prescribe analytics or expert system or the recommended system. We prescribe the patient. We quit the tobacco, right? Then if you wish to change your status from your heart disease from present to absent, you need to quit the tobacco. Fine. But however, just I wanted to add some kind of the funny elements into this presentation. But sometimes the doctor also experience a very adamant patient, right? You may also experience a situation, right? Say a patient is visiting a doctor and he's a chain smoker or he's a heavy smoker. And doctor asks, like, you need to quit tobacco, right? If you wanted to change your status. Sometimes it happens, the patient, they do not quit tobacco, they quit the doctor, right? So, what is such kind of the situation also arises in the practical world. If the customer or the patient will quit the doctor will be losing the revenue. The patient must be visiting like twice in a month or once in a month, right? Suppose they get such kind of the customer. So let's do a simulation into that. Suppose we experience such kind of arrogant patient, what to do that? Tobacco intake, let's put the 2, let's put the medium. Let's check the status now. No, it's not working out. Let's put 1. Let's put low. Let's check the status. How is it? So again, like I do not wish such kind of the recommendation. This is a disclaimer, but what you can figure it out, right? Suppose you experience such kind of the adamant patient, also you can recommend if you don't quit, right? You don't quit immediately, right? You can consume a one tobacco, but still you can keep your heart disease status intact. Fine.
Sir,
So
but the obesity is actually overweight and stress level is also present. Cholesterol level is also present.
This is a dummy data, man. You know, it's not a real data, it's a marks data. Are you getting me?
Yeah, okay, sir. Okay, sir.
It's not a real data, right? It's a marks data for the purpose of demonstration. But what we can claim here, basically, we are talking about the framework, the CRIPS framework, right? The business understanding, data preparation. Until the data preparation, we are done because this is more into a clean data. And rightly pointed out, this is the marks data, right? So, and what the model we have used, you see below the prediction of heart disease, you see through the CART model. We have used an algorithm called classification and regression trees that comes from the decision science or decision tree family. But again, we are going to experience all this in the real time in a click of a button. Fine. And we have done all the evaluation after the model building. We have done the evaluation by using the confusion matrix, ROC, AUC curve, gain and lift chart, right? Then we have deployed this model. So suppose I take back the CRIPS framework, what I was talking in the beginning, you need to follow a CRIPS framework, then your chances of completion and winning will be much more higher, in between 40 to 50%. So this is the way you get, right? So let's see how you do that. I'm closing this, and we have a defined time frame. So if you have any queries, we can do that. So as I was talking about, I am using a software called Statistica. You can view my screen now, a blank screen, the Statistica screen, the interface. Can you please prompt someone from the
Yes, sir.
Yeah, so I wanted to solve this problem practically. So the Statistica, as I said, it's a data science platform with a no coding and the low coding tool. You need not to write a single line of the code in order to solve this heart disease prediction problem. Fine. So I went to the data mining. We have a very advanced feature called data miner recipe, right? I went to the data miner recipe, but in that case, how I came to the conclusion, the classification and regression trees is working fine because I do have all the algorithms. I do have classification regression tree in Statistica. I do have chat model. I do have interactive trees. I do have boosted trees. I do have random forest from the assemble model, right? The boosted tree and the random forest are the assemble model. I do have the neural network. I do have machine learning. Under the machine learning, support vector machine, knee-based classifier, k-nearest, all algorithms are capable to apply and solve this my prediction classification problem. Fine. So what I have decided, I will not rely on my individual wisdom, right? I wish to go for a collective wisdom, right? Let my software recommend me on the basis of the evaluation, which of the model is working fine. So I went to the data miner recipe. I got my data set, open connect data. Can you view my screen? You can, these contents are legible, the features are legible. The reason I'm asking again and again, like suppose you ask me after this session, sir, please share us the link. We wanted to give a try. We have some of the ad hoc projects because we are committed to SPC, like we stand by to support you. Right? So that is the reason. All this content you can view, right? Can you view the content? Can you read the content?
Yes, sir.
Visible.
Hello.
Yes, sir.
Okay. So I'm opening the connecting the data, the hard disease data, what we saw, the 460 live. I am not like the applied data transformation. I am not doing that in best interest of the time, right? But suppose you wanted to transform the data in terms of the standardization, in terms of the transformation, we have in Statistica a whiteboard. We have got a function library, right? So you can write any of the functions which will do the mathematical computation in the backend, right? I'm skipping and in best interest of the time, then select variables as usual. So here, you please see, if I uncheck the show appropriate variables only, there is some kind of the confusion, which is the categorical, which is the continuous, but Statistica helps you in order to reduce the confusion. If I check box, so appropriate variable only. If I click here, these variables are classified on the basis of their characteristics. Are you getting me? So these variables you see now, the continuous has been classified in the continuous column. Categorical has been classified in the categorical column. So I go into the coronary heart disease. I select this. I select this, right? These are my input. Okay. Let's go. It's more into a guided analytics. I go to the next. I'm going to the next. I'm skipping many steps, right? Just I will show you the report, how it generates. Again, suppose you wanted to do some kind of the data redundancy. right? Or which is popularly known as the collinearity also. You can define your threshold value for the correlation, right? Again, I'm skipping this. Right? You can import a variable annotation. What we did in this variable screen, I'm skipping this. Here, as I was talking about, I don't rely on my individual wisdom. I may be an expert in classification regression tree. So my reviewer may ask me, what made you to choose the classification regression tree? So I don't rely on my individual wisdom. I'll be going with the collective wisdom, right? So here, by default, it has chosen classification regression tree, boosted tree, neural network. Again, I will check box the random forest assemble model and the SVM also. In addition to this pipe algorithm, if I do have the mole algorithm, I can load from the, suppose I have applied the logistic model or any other model, and I have saved this model in the PMML, I can load as many as model I have, model comparison to get the best accuracy from the model, right? So let's go. Okay, can you view my screen? Hello? Can you view
Sir,
my
yes, sir, it's
screen?
visible, sir. Visible.
Okay, so what do you, yeah, what do you can make it out from here? You see some like SBM, postcard, random neural network. What do you can make out from this screen? What do you can make out from the screen? What I can make out from the screen, as I said, I want to approach and solve this prediction of heart disease. I applied 5 appropriate algorithm: support vector machine, boosted tree, classification regression tree, random forest, neural network. Out of these 5 algorithms, the support vector machine, SPM, right, which is the minimum error rate of the 10.80 indicates, right, the support vector machine is what you more deeper investigation and the deeper study using the SPM. So I have now enough evidence to suggest my reviewer or my stakeholders. No, I applied all the possible algorithm and I have the enough evidence to suggest the SPM is working fine, right? And what the report it is generated in the background, summary resolved all states. It take a while, so it is not slow because so many computation has happened, right? So many computation has happened. Data analysis, data redundancy, user target variable escape, right? Important variables we have skipped. Model building, part, right? Tree graph. So you get that tree graph, how the tree has been split, tree structure, predictor importance, misclassification cost, right? You can define the misclassification cost. I get cross tabulation, or what you primarily known as the confusion matrix. confusion matrix. I get a confusion matrix. Can you view my screen, please?
Yes, sir.
Yes, sir. No issue, sir. Please.
No, you can view what you can view from my screen.
The programming, sir.
What? What
Sir,
program? What is the language is this?
Code.
Yeah, this is the code. This is the C++ deployment code,
Yes, sir.
right? So
Yes.
this also has been generated as the output, although we do not sell to the academics, right? So, right. So this also, the program has generated the code. It has generated the code for the C, C++, C sharp. This also has generated the code of the C sharp. Fine. So what you saw the API, the API, this prediction of the heart disease, this is the result of this C sharp development. We got this code, we built an executable file, exe file, right? I'm not a coder, right? My people did it for me, right? So you must understand better than me, right? You are academician, so you understand better than me. So we got this code, right? We created, and I get 100,000 lines of the code error free. You cannot make it out a single error from this code. And suppose, depending on the expertise, if I asked anyone to write the code, it may take month and year, right? So this is the power of the tool, and this is the way we have deployed this API. Fine. Yeah. So we are running out of the time, right? So yeah, you can open for if any queries or anything has emerged during the session. I would be more than happy, or I would be more than happy and try to answer those queries right away, or I can take it offline, right? It totally depends on the organizer, definitely. So please, organizer, you can open because we are approaching to our time. I do not know how much. In my watch, we have another 5-10 minutes. So you can open the question and answer session for the audience. Hello? Hello?
Sir, dear participants, anyone wish to interact with the expert, you can unmute yourself and ask the questions.
I have a doubt.
Sir, please
Can I
speak
do it
loud,
for
sir.
cancer? Can I do it for cancer detection? Because lot of parameters are involved.
Yeah, there is no problem. But see, either it could be a cancer, it could be an employee attrition, it could be anything, right? Because broadly, as a data scientist, if my target are level with classes, I am solving a classification problem, irrespective of the domain. That is the most beauty and the power of data scientists. It could be the data could be from any domain, right? So I need, if I follow the same of like the workflow of the CRISP framework, right? You can do that. And as you said, I deal with a very large number of parameters. You have the power and you understand your data better by applying the feature engineering or the feature selection. You can include or exclude the parameters on the basis of your defined threshold. Yeah, does it answer your query, sir?
Yes, yes. Thank you.
Okay, fine. Thank you.
Any other participant?
Sir, Roslyn here.
Hello, sir.
Good afternoon, sir.
Very good
Could you
afternoon,
please,
Roslyn. Yeah, can you please background this
could
because
you
there is a
please
lot of
share
noise
the
from the
recording,
background.
sir?
President Madam, please unmute yourself and ask the question.
Hello, sir.
Yeah, I can
Sir,
hear you,
can
ma'am.
you hear me? Sir, can you
Yeah,
hear me? And Roslyn here.
Yeah, Roslyn, ma'am. I can hear you, ma'am. Please.
Sir, could you please share this recording with us so that we could, follow the steps that you had done, which could be helpful for our research in future?
Yeah, the host can answer better than me, ma'am. Over to host.
We are recording the session. At the end of FDP, we are providing the recording sessions through YouTube channel, madam.
Ranjit Nagaru, thank you very much. I think your session was completed. I join now. Biswajit sir, thank you very much.
Okay, no problem.
Hello,
Thank
sir.
you. Signing up for now. Thank you very much
Thank
for
you,
your
sir.
time
Have a
and the
nice
patience.
day. I think we'll meet you again online.
You too.
And
So all the best and success.
Dr. Nayak,
I
what
will
is a
discuss
small
offline. Thank you.
Dr.
I'm
Nayak?
signing up now. Bye bye. Take care.
Just a minute, Nayak.
Yes,
Dr.
sir.
Nayak, we are going to plan an offline session in the end of June or starting of July.
Yeah, we'll see, sir. Then.
Then
Right,
I
we'll
will
talk.
discuss with you because you are
Yeah.
a big
We'll
corporate.
be
You are
discussing
part of.
offline.
And then that's
Yeah.
it.
Right.
Thank you
We'll
very much.
stand by.
All the best.
Thank you. Thank you very much for this opportunity and platform. Signing up for now. Have a wonderful day here, all the participants. Bye bye. Take care.
So next expert has joined and
Yes, sir. I'm checking, sir.
next.
Sharda madam, Dr. K. Sharda madam.
Madam is already there and madam on sir. Yes. But as a June is on 2
Madam?
o'clock. With the other lady, that B. Sarada, but we are waiting for the resource person. We can wait till 2 o'clock and.
Okay, sir.